Welcome to lecture 5, where we are going to solve some important problems on complex numbers with tips and tricks. First question: if x minus iota y is equal to root over a minus iota b by c minus iota d, then to prove that x square plus y square whole square equal to a square plus b square by c square plus d square. Okay, x minus iota y is equal to given root over a minus iota b by c minus iota d. In the solution of any complex numbers, we need to convert the number first in the simplest form of x plus iota y. In this problem, you must multiply the denominator with the conjugate of c minus iota d, numerator also with the same terms. Now we should simplify the terms. In the numerator, ac plus iota ad and minus iota b into c, so minus iota bc, then minus iota square bd root over divided by d square minus iota d whole square equal to ac plus bd, because iota square is equal to minus 1, so minus minus plus we are getting bd, and here common iota into ad minus bc by c square plus d square, because iota square will be minus 1. X minus iota y whole square will be equal to, okay, implies x square minus 2x iota y plus iota square y square is equal to these two terms we are getting. Comparing the real part and imaginary parts from both the sides, we get x square minus y square is equal to ac plus bd by c square plus d square, and minus 2xy is equal to ad minus bc by c square plus d square, implies x square plus y square minus y square giving whole square. Then how to balance this quantity? If we add 4x square y square, okay, after getting here minus 2x square y square, ultimately it will remain 2x square y square equal to x square minus y square whole square plus minus 2xy equal to ac plus bd by c square plus d square whole square, okay, then plus ad minus bc divided by c square plus d square whole square equal to c square plus d square whole square, and here f square c square plus twice ac bd and plus b square d square, and here plus s square d square minus 2 ad bc plus b square c square. Further simplify, c plus 2 ac bd cancel with plus 2 ac bd, and remaining here s square c square, and you see that again s square d square. So from these two terms take common s square, so c square plus d square. After that, remaining other two terms plus b square d square and c square b square c square. So here b square common, so that c square from this term, and plus here b square remaining d square, okay, and divided by c square plus d square whole square equal to a square plus b square and c square plus d square, c square plus d square whole square. See, c square plus d square will be cancel, equal to a square plus b square by c square plus d square. Hence proved, okay. Write nicely, x square plus y square whole square equal to x square plus b square by c square plus d square. Next question, let z1 is equal to 2 minus iota and z2 equal to minus 2 plus iota. Then find the real part of the product of z1 into z2 by conjugate of z1, and the imaginary part of the reciprocal of z1 and z1 bar multiplication, z1 into z2 by z1 bar is equal to 2 minus iota into minus 2 plus iota by 2 plus iota, because z1 conjugate is this 2 plus iota into 2 minus iota, and here 2 minus iota into minus 2 plus iota and 2 minus iota. Simplify. Here a square minus b square form, so 2 square minus iota square, and here 2 minus minus iota and 2 minus iota, it will be 2 to 4, and then 2 iota into 2 and plus iota square and remaining this multiplication minus 2 plus iota equal to here 4 plus 1, and here 4 minus iota 4 minus 1 into minus 2 plus iota equal to 4 minus 1 means 3 minus iota 4 here into minus 2 plus iota by 5 equal to 5 in the denominator, and here minus 6, then plus 3 iota, here minus minus plus 4 into 2 8 iota, and here minus iota square into 4 is equal to minus 6, and this is coming as plus 4, and then 3 plus 8 iota is equal to 11 iota by 5. z1 into z2 by conjugate of z1 is equal to, ultimately we are getting minus 2 plus 11 iota by 5 is equal to minus 2 by 5 plus iota 11 by 5. Okay, therefore real part of z1 into z2 by conjugate of z1 equal to minus 2 by 5. Similarly, we can find the next part. Reciprocal of z1 and the conjugate of z1 is equal to 2 minus iota and 2 plus iota. Okay, so very easy to understand, a plus b into a minus b. So a square minus b square, 1 by 2 square minus iota square equal to 1 by 4 plus 1 equal to 1 by 5. This can be written as 1 by 5 plus iota 0, because imaginary part is not there, but we can make it. Okay, so what will be the imaginary part of that? Im of z1 into z1 bar is equal to 0. This is the answer. Okay, third problem. For any complex number z1 and z2, we have to prove that the real part of the product of z1 and z2 is equal to real part of z1 into real part of z2 minus imaginary part of z1 into imaginary part of z2. Okay, let us see the solution. Means it is a proof actually. Let z1 is equal to x1 plus iota y1 and z2 equal to x2 plus iota y2. So therefore z1 into z2 equal to, by putting the values, x1 plus iota y1 into x2 plus iota y2 is equal to, simplify, x1 x2 and then x1 plus iota into x1 y2 and then plus iota y1 y2 and then plus iota y1 into iota y2, so iota square into y1 y2 equal to, we can write x1 x2, and these are iota mixed, but here also iota mixed, but iota square is minus 1, so plus minus minus y1 y2, and here these two terms iota can be taken common, so plus iota into next, sorry, here y1 x2, this is y1 x2, so plus y1 x2 is equal to, so see here x1 x2 minus y1 y2, real part of this product, and this is the imaginary part, x1 y2 plus y1 x2, So real part of this product is this, and this is again we see that in Z1 x1 is the real part, okay, and x2 is the real part of Z2, and then minus y1 is the imaginary part of Z1 and y2 is imaginary part of Z2. So therefore real part of Z1 into Z2 is found to be equal to a real part of Z1 into real part of Z2, and then minus y1 is the imaginary part of Z1 and y2 is imaginary part of Z2.